This is Algebra 2 with Trig. We're working on rational equations and expressions. Here we're just simplifying, so we have to factor. Looking for two things that multiply to be 16 and add to be -8. Multiply to be 24 and add to be +2. So our final answer is x minus 4, x plus 6. Here we have the difference of two cubes. So we have a rule for the difference of two cubes. So if we have the same thing that's a term being cubed, and if this is a term being cubed, then we would have a minus b, square the a, change the sign, multiply the two together, and square the b. So this is going to become x cubed minus 5 cubed, because 5 cubed is 125. So this is going to be x minus 5, and then you square the x, change the sign, multiply the 5 and x together, then square the 5. Then this is the difference of two squares. Those cross off, and we get x squared plus 5x plus 25 over x plus 5. You cannot reduce around a plus sign or a minus sign. Okay, now we're multiplying together. Well, these are all monomials. There's no adding and subtracting going on. So we can just reduce. It's like one giant fraction. What I notice is that my 3 can go into my 27 9 times, and my 5 can go into my 15 3 times, and then my 3 can also go into my 9 3 times. So what that's going to give me is a 3, x to the 7th power, y to the 3rd power. On bottom, I have x to the 5th power, y to the 5th power. So then I can reduce one last time. That's one way to do it. A couple different ways to organize that, but that's the final answer. With division, we don't actually divide fractions. We're going to factor, but then we are going to multiply by the reciprocal. And I'm going to factor at the same time I do that. So we get 2 and 1, minus and minus. So x plus 2 and x plus 2 and x minus 2 and x minus 2. So it looks like I'm left with a 2x, actually a 6x, sorry. And an x minus 2, x minus 1. Does that look right? Checking my work. Well, that looks good. Now, when we're adding two fractions together, we need common denominators. Hey, look what we have. We have 2 plus x over our common denominator. If you want to write that in the other order, that's fine. Multiplying again. Six and 3 multiplies to be 18, adds to be 9, and we multiply So the x plus 3's cross off. The x minus 6's cross off. So it looks like we have x plus 6, x minus 3. Well, this one up here is actually x plus 3, x minus 3, so I'm just going to cheat and do both of those at the same time, and I don't have to rewrite it by factoring that apart. So it looks like I have x cubed. Okay, this one, we're not multiplying by the GCF because it's not an equal sign. We're not trying to get rid of items, we're trying to get common denominators. So we have x minus 1 and x plus 5. And 3 times x minus 5 over a common denominator. We have to FOIL this together. So now what we have to watch for is to distribute our negative through. And then we collect all our like terms. That's going to be ugly. Negative 4, so that's negative 3. Plus 3 more, so that's out. 3, that's 8. Negative 7. Something like that. So on the flip side, we're going to work with complex fractions. So I'm noticing that this is actually factored. I don't want to rewrite the whole problem. This is actually factored out to be 2 times x minus 1. So my LCD has to be the 2, has to be the x, and has to be the x minus 1. So that's my LCD, least common denominator. And I'm going to multiply that to all the tops of the little fractions. So then we can start reducing. And this is where some people had troubles in the past. When you reduce x with 2x, that does not become 1x. That just becomes the value of 2. The x's go away. 2x divided by x is just 2. So I have 2 times 2, which is 4, times x minus 1. On this side, the x minus 1's go away, and I have 6x Here the 2's go away. The x minus 1's go away, and I'm left with x. So we have 4x minus 4 plus 6x. And it looks like we have 10x minus 4 over x. The x's cannot cross off. Cannot cross off because that's actually 10x minus 4. So on this one, we have an LCD of 3 and x plus 2. So if every denominator was 3x, x plus 2, then everyone would be happy. This would have an x plus 2, this would have a 3, this would have an x plus 2, this would have an x, if they all were that. That's what a least common denominator is. So we're going to multiply that value to every numerator of the small fractions. So we're going to cross the 3. Now what are we going to do? We're going to cross the x plus 2's off. That's going to leave us with 3x. Actually 3 times 3x. And the 3's are going to cross off. So we're going to have 2x times x plus 2. That gives us 6x squared. That doesn't become 2x, that just becomes 3. So we have a negative 3 times x plus 2. So we have 9x plus 4x squared plus 4x. That's actually going to be 2x, isn't it? 2x squared. Go back and check my workout. And then here we have 6x squared minus 3x minus 6. We can reorganize that a little bit. This makes 13, it looks like. 13x. And down here, we could pull the 3 out of that if we wish. We get 2x squared minus x minus 2. That's what I came up with. Alright, notice that this type is a proportion. So really all I need to do is cross multiply. X squared plus 7x, negative 6. Bring that guy across to become positive 6 and factor it apart. So you get x equals negative 1 and x equals negative 6. Negative 7 would have been my extraneous solution. But I didn't get that, so I'm okay. So we have 2x minus 6 times x plus 2 and x times x minus 6. Four minus 6 is negative 2. Multiplying through, collecting our like terms, adding our 6x. So that's x squared plus 4x minus 12. That looks like 6 and 2 to me. x plus 6, x minus 2, that multiplies to be negative 12, that adds to be 4. So you get the answer of negative 6 and positive 2. Positive 2 works, negative 6 would work. We're good. And finishing up our last 4 questions, I noticed that this is factorable to be x minus 3, x plus 3. So my LCD is going to be x minus 3, x plus 3. Because we're working with an equation, an equal sign, I eventually just want to know what x is. So I have stuff to cross off. So what I'm going to do is take my LCD and multiply that across the top. Now think about what that means. That means that I'm raising this equation by the same amount to every term. That's why it's equivalent. That's why it's okay to do this. So I'm going to cross off my x minus 3, and I'm left with 4 times x plus 3 plus 2 times x minus 3 equals, all of that crosses off with all of that, and I'm just left with my 2x plus 2. No need to factor that apart. No need to pull out the GCF, because I'm going to put them all back in here. 4x plus 12 plus 2x minus 6 equals 2x plus 2. That's 6x. That's 6. Subtract your 2x across. Now notice that the x's are the same type. We've talked about this. So I'm going to subtract the 6 over here. I'm trying to get x by itself. So it looks like I'm going to get x equals negative 1. And negative 1 would be okay. What I couldn't have is a 3 or a negative 3. Those would give me extraneous solutions. I got a negative 1, so that looks okay. So what do you see with this one? What's our GCF going to be? Well, pretty clear. It's just the same number, so it's x plus 6. That's my GCF. It's an equal sign, so it's an equation. So I'm going to use x plus 6, x plus 6, and x plus 6. Nothing to cross out here. You cannot cross the x's off. Nothing to cross off. So I have x times x plus 6. There's no denominator, so I have nothing to cross off. This denominator can cross off with it, so I'm left with a 5. This denominator can cross off with it, so I'm left with a 6x minus 1. And I have different types of x's, so I'm going to bring them over. Well, this is kind of weird. So I'm going back to check my work real quick. Alright, when I brought that over, that's a plus and that's a minus, so that's gone. This makes 6. I'm getting x squared plus 6 equals 0. So I'm getting an imaginary number. So what that would tell me is that there is no real solution to this one. I might need to go back and check my work. I wasn't expecting that. But before I do, let's try to finish this up. Number 19. The braking distance of a car can be modeled by, where d is the distance and s is the speed at which the car is traveling. Find the speed, so find s, when the braking distance is 240. So the distance is 240. It tells you what to do. So this might help explain where one thing you could do is multiply everything by the denominator, just like we usually do. So I'm going to get 4800, so 4,800, 20s plus s squared. So that's going to give me s squared plus 20s minus 4,800. And I suspect that that's factorable. We'll have to think about that here for a second. I know I'm going to have s's. I know that my signs are going to have to be different. We need to come up with two things that multiply and add. All right, with a little planning ahead, I'm working with this 48,000. So let's just narrow that down to 48 and think about what your multiples are to make 48. 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. 6 and 8 are 2 apart from each other. And if we wanted to get up to 4,800, we would need 60 and 80. So I think we're going to use 60 and 80. So we'll have to have negative 60 and a positive 80. There we did it. Your speed would have to be 60 miles per hour, because it's not going to be negative 80. It's going to be positive 60. There we did it. Last one. This baseball season, you had a hit 12 out of 60 at-bats. Write and solve an equation to find out the consecutive hits you need to raise your batting average to 36%. Well, you have 12 out of 60 at-bats. That's like 20%. So we need to increase our bats, but that's also going to increase our at-bats. Those are our hits, so our at-bats increase also by the same amount. And we want that to equal 0.36. So let's see. Let's not use 0.36. Let's use 36 over 100. Because then I won't feel as stressed about decimals. That's 1,200 and 100x. This would be 36 times 6, 108, with another 0. So I think that's 1,080 plus 36x. We can test that if we need to, I guess. 36 times 60. Oh, 36 times 60. That saves us. Okay, seems to be not that. Where'd that theory go? 2160. Oh, yes. That's 1819. Anyway. So we're going to subtract our 36x. That's going to give us 64. 90, 100, yep, 64x minus 1200. So we'll subtract our 1200. So that's 960. A little off today. And then we divide that by 64. 15. You need 15 more at-bats in a row. Well, if you had 12 at-bats out of 60, how are you going to get 15 in a row? But good luck. Get that batting average up.